Good evening, welcome to my laboratory. Okay, that's the signal from the drain of the MOSFET, or if you like, the coil signal from the MHOP pulse motor. The zero baseline is that radical marker right there, and I've got the spike on the centered radical marker so that we can tell if it moves left or right, if the rotor is speeding up or slowing down. Right now it's turning about 1360 RPM. And I've set the duty cycle, as you can see there, to be about 50% or a little bit less than 50% on. And I chose that because it gives me an input current of about 100, I tried to get it close to 100 milliamps input. Okay, and I've got the strobes turned off. I put a little switch here so that I can turn the strobes on or off. Thanks to Pirate for the switch. And with the strobes off, we have about 101. With the strobes on, it goes up to 117. So the strobes are costing 16 or 17 milliamps. So I'm going to turn the strobes off. And what I want to do is show what happens when we power up the little ring oscillator. Okay, so what I'm going to be doing is just touching it across. When I touch it across this neon will go out until this capacitor is all charged up, and then this neon will come back on. So what I'm going to do is just touch the thing across the terminals, let the capacitor charge up until it's fully charged, and at that point one of the the run neon came on, so now I know I'm back to stability, and then I'll take this off. Okay, and what we'll do is we'll look at the effect of that procedure on the current and on the RPM and the development of that spike waveform. Okay, so first I'm going to show, well, let's see. Okay, first, so let's go ahead and discharge this guy. I'm doing all this with one hand. Alright, so that's discharged now. Now watch the current as I do that same procedure. Okay, in contact now. You see the current went up for a second, and then it actually goes down below the level that it was running at. So here we're charging, and the current is below the run level until, boom, the run neon comes on and the current goes back up to the run level. Okay, and of course that makes the ring oscillator run. Alright, now the RPM is staying constant during this, so let me go ahead and discharge this now. Alright, now we'll do the same thing again, except this time looking at the scope trace. Okay, now when I first make contact, you'll see that spike change right there. And now look at it rising. That's the capacitor charging. Charging, but the RPM has not changed. It hasn't moved left or right. Boom, now the run neon is on, and the spike will develop a little bit higher than that once I actually remove the ring oscillator. Okay, and there's the spike gone up. And you can see that the RPM stayed rock solid during that. The trace would have moved to the left, or to the left if it sped up, or to the right if it had slowed down, but it didn't. Okay. So, boom. Let's look at the current again. This is input power. Alright, so here we go. Contact. So there's that surge of current, and then the current actually goes below the level that it was at while it was running until the run neon comes on. Now it's back up to the level that it is when it's just running without a load. And of course the spike. Let's see, let's do it again. So here in contact now. Run neon just turned on. And so now we'll remove the ring oscillator. Alright, so what we've seen here, when I hook up the external load to siphon off that spike into the ring oscillator, we get a brief surge of current when it first starts charging the capacitor, but then the current draw actually goes down below the level that it's at now, the run level, while it's powering the ring oscillator, and the RPM does not change. Okay. Now some people might want to make a big deal over that. Me, I need more data. Thank you for watching.